Welcome to this video on the modulus argument form of a complex number. And this is FP1 unit 1.6. So basically it's quite a straightforward one, but for a complex number, say z, where the modulus of z is r and the argument of z is theta, then the modulus argument form of z is simply going to be r cos theta plus I sine theta. So if we picture it in an argon diagram, we would have something like this. So this is going to be my z, and it's going to be x plus I y. Okay, so if I think of these horizontal and vertical distances, that's going to be x, that will be my y distance. And this basically vector will be r at the angle of theta. Well, that r doesn't look wonderful, let me just redraw it. That's a bit better. So just in case you're unsure, kind of where this comes from, just think back. So we'll go through it step by step. So z is going to be x plus I y. We know that from previous. And if I think of using Pythagoras, we've got a right angle triangle here. So if I look at x and I wanted to find x, so think of this being, if we look at cos theta, is going to be the adjacent, which is x over the hypotenuse. Therefore, x is going to be the equivalent of r cos theta. So coming back over here, I can replace x with r cos theta. Now when I look at doing the same thing to find y is going to be within the sine. So sine theta is opposite over hypotenuse. So sine theta opposite over hypotenuse. So again there, y is going to be r sine theta. So again, replacing my y, so it's got the I there, I r sine theta. And then we have r in both, so factorising out the r. And that's what we get. So that's where this form comes from. Okay, just thinking of the argon diagram and essentially using Pythagoras. And it's just a different way of writing it. So it's nothing, essentially super new. It's just going to be a different way of writing it. You're going to see it come up, and it's quite useful. Now, the argument theta is usually given in the range between minus pi and plus pi. So it's usually, I'll put it down here, it's usually in the range of minus pi to plus pi. Okay, but that said, the formula is going to work for any value of theta measured anti-clockwise from the positive real axes. Okay, so it will work for anything, as we know the way kind of trigonometry works. So now let's have a little look at converting between different forms. Now with this example, you can see we want to express z equals minus root 3 plus 2i in the form r cos theta plus I sine theta. Now when you're doing something like this, easiest place to start is with a quick sketch of the argon diagram. So in my case, minus 3 is going to be to the left, and then 2 on the imaginary scale, so it's 2 up. So it's going to be something like this. So just tidying it up a little bit. So we've got our z, and we've got minus root 3 across, and we've got 2 or that 2i up, 2 in the imaginary direction. Now remember that when we measure our argument of z, that's going to be measured anti-clockwise from the real axis. So it's going to be this here. So this is our arg z. And this angle theta, or I'm just going to use alpha, kind of just use either or. Sorry, I just realised I made a little mistake. Let me get rid of that z. That's not the z, because z is our minus root 3 plus 2i. This distance, this kind of diagonal distance here, is r. So the first thing I want to do is find out what the size of r is. And this is just going to be, again, Pythagoras. If I think of this, it's going to be this squared plus this squared and square rooted. So square root of 2 squared plus my minus root 3 squared. So 2 squared is 4, root 3 squared, or minus root 3 squared, is 3. So this is going to be root 7 here. Now next I want to find theta. Now theta is my argument of z, my arg z. And this is basically now going to be pi minus that value of alpha. Now when you come to do this, you just want to be working out that acute value of angle, value of alpha. So you need to be careful with this bit. Yeah, you're actually just going to use the positive values, because to find alpha, what you need to think about is, right, well, tan alpha is opposite over adjacent, like that. So the size of alpha is my arctan or inverse tan of that 2 over root 3. It's just something to be careful of. You can see I've put my minus root 3 because we're going in the minus direction. But if I use that minus value, it's not going to give me the right angle there. Okay, so the easiest way of doing this so that you don't make a mistake in further questions is to use the two positive ones. So alpha is 0.857 there to 3 significant figures. Some of these are nice whole numbers, and I'll do one with a whole number in a moment as well, just to show you the two. So we've got now pi minus 0.857, and that is 2.28. Again, I'm just doing this to 3 significant figures. Obviously, these questions usually do tell you that. Now all I need to do is apply this to my original kind of statements. We know that z is going to be root 7, because that is my r. And then we got cos 2.28 plus I sine 2.28. And that's all there is to it. Let's have a look at another one. So same kind of question, just start off by using the argand diagram. So we've got minus and a minus, so we're going to be in that third quadrant there, the bottom left one. So here we have it with our z minus 3 minus 3i. And what I'm going to do this time is I'm just going to put on the positive distances rather than the actual values, just to hopefully make it a little bit easier not to make the mistake. Again, alpha here. Now, since this is given in the range between minus pi and pi, as is usually the case with these, you just need to remember that in this kind of case, then the argument of z is going to be here. And this is all to do with what's called the principal agreement. Basically, if you think of this being our real axis and our imaginary axis, if it's between here, 0, and our 180, then we're going to be measuring this direction. And then if you go from 0 to minus pi, we start to measure in this direction. So if you remember using the cast rule in your pure maths, when you're going in a positive direction, you are going anti-clockwise, you keep going this way. And then when you want to go negative angles, so below 0, you'd go in the clockwise direction. So just remembering that, because we're going not between 0 and 2 pi, which would be one full circle, we're going between minus pi and pi. So that means from 0 to pi is this way, and from 0 to minus pi it's this way. So just remember that when you come to these questions. Anyway, let's get back to it. So r is going to be 3 squared plus 3 squared, and then square rooted. Obviously these are actually both negative, but you know, even if I put the negatives in, it doesn't make a difference, does it? So we've got 9 plus 9, so we've got the square root of 18. Or I can write that as 3 root 2. So there's my value of r. Now theta is obviously my argument of z. And then here we need to work out what we are doing. So if you think of this, and I'll put these values in red, if you think of our 0 angle or 0 line, we're going in this direction. That's going to be minus pi by 2, carrying on in this direction all the way up to minus pi here. So to find the argument of z, we're basically looking at minus pi plus alpha. So minus pi plus alpha will bring us this value that is between minus pi and minus pi by 2. Okay, I've written it in red there, but I think in a previous one, there's another way of looking at this, so you could call this minus, and then it's pi minus alpha. And the reason I'm looking at it this way is if you've got your diagram, you know, and you're going from 0 basically to pi, you know, this is going to be just alpha, this is pi, if I put the alphas in, minus alpha, let's put them all in, this one be minus alpha, and this one be minus pi minus alpha, like that. So using this kind of thing here just makes you remember, you know, if it's on the right hand side, it's alpha or minus alpha. If it's on the left side, it's pi minus alpha, the positive, or pi minus alpha, the negative. And it's an easy way of remembering it without making a mistake, because I do see a lot of mistakes with what to do at this point, getting mistakes like minus pi minus alpha, where minus pi, if you minus alpha, you're going to carry on into a greater negative angle. Anyway, let's work out what alpha is. So tan alpha is going to be 3 over 3, isn't it? Opposite over adjacent. So alpha is pi by 4. So we've got minus pi minus pi by 4. So that's going to be minus 3 pi by 4. Now let's put it into the right form it wants it. So r is 3 root 2. And then we've got cos minus 3 pi by 4 plus I sine minus 3 pi by 4. Hopefully very straightforward, and hopefully you can see, you know, sometimes you will get whole values, or not whole values, I should say exact values, like your fractions there, or your thirds, and you should use exact values where you can. Okay, final example. This one we're going in reverse. Hopefully shouldn't be too difficult. Again, let's start off with a nice argand diagram. Okay, so thinking about this angle here, 2/3 of pi, where's that going to put us? It's going to put us in our second quadrant, isn't it? Yeah, so you think this size here is 2/3 of pi. Okay, make it a little bit smaller. And we know that this r is going to be 4. So we got that distance there. We also know that alpha is going to be pi by 3, don't we? Because obviously these two are going to add up to 180 there, or pi. Now from this now we can work our way backwards, can't we? Because we know what r is here. If I label these x and y, it's just a matter of finding them out now. So for example, if I want to find sine alpha, is obviously opposite over hypotenuse. So we got sine pi by 3, the opposite is y, and the hypotenuse is 4. So that will tell me the value of y now. So y is 4 sine pi by 3. Jump into my calculator, and that is 2 root 3. And doing the same with cos. So cos pi by 3 is adjacent over hypotenuse. So exactly the same thing, just jumping straight to your calculator, and we get 2. So now we can say that if you think of this as x, I, y, is going to be 2 plus 2 root 3 I, or stick the I first, sometimes I do in ones like this with a square root and stuff. But yeah, that's all there is to it going in reverse. Very straightforward, potentially a little bit quicker going in reverse. Anyway, thrown together just 4 fairly straightforward questions so that you guys can have a little practice, and I'll pop the answers at the end of the video. If you have found the video useful so far, don't forget to hit the like, subscribe button and comment down below.